So we'll start in another few minutes. Okay. Recording. Yeah, I think you can start the recording also. We'll start at another 2 minutes. So 6:05, we'll start the meeting. Then let the people can also join. Okay. Good evening, friends. On behalf of Computer Society of India, Chennai chapter, IEEE Computer Society, ACM Chennai, and PHA Learning, I have great pleasure in inviting all the participants and guests of today's meeting. In fact, we have two special guests apart from the speakers who are going to present today's presentation. The first guest is Mr. Ghosh, who is considered as the father of Indian publishing and the current chairman and managing director of PHA Learning Private Limited. Earlier it was known as Practitioner of India. Mr. Ghosh is known for his vision and strategy for internationalizing higher education publications and pioneering low-cost, world-class books on a mass scale in the early 1960s. In fact, I was one of the beneficiary of the books by Prentice, which was then called as Eastern Economy Editions. From 1970s, I have been using these books. Over a period of 5 decades, Mr. Asoke Ghosh has published over 5,000 titles in various disciplines. His idea of publishing low-cost books at affordable price intended to cater the needs of Indian students, especially from economically weaker section, is praiseworthy and commendable. He has significantly contributed in providing platform to the authors for inheriting their knowledge to the students of the next generation. He had foreseen how the computers and computer publishing could influence the education in India and thus published the first book on computer science in India, Principles of Computer Programming, authored by Professor V. Rajaraman, who is our fellow and lifetime achiever of Computer Society of India. Mr. Ghosh has represented India in international book fairs to promote homegrown publications and Indian academia all over the world. Mr. Ghosh is a founder member of the Federation of Indian Publishers and Indian Reprographic Rights Organization. Now he is the President Emeritus of FIP and Honorary Advisor for IRP. Mr. Ghosh has several awards to his credit, such as the Simon Master Chairman's Award, the most prestigious award in global publishing, most distinguished publisher award and lifetime achievement award from the Federation of Indian Publishers, Saraswati Samman, Shri Kumar Kunda Award, Kuldeep Anand Award, Diodayal Mehra Memorial Award, to name a few. Due to his large effort, Delhi was declared as the World Book Capital for 2003 by UNESCO. He is the first Asian to become the Vice President of International Publishers Association. For promoting reading habit among the public way back in 1991, the International Publishers Association gave him the highest outstanding leadership award. He was instrumental in bringing the 24th IPA Congress to Delhi first time in 1992 and again in 2018. Mr. Asoke Ghosh devotes himself to humanitarian services, including free education, healthcare, through Rimjim Ghosh Foundation in memory of his younger daughter. Additionally, he is an outstanding Rotarian for the past 43 years, apart from serving as Rotary District Governor in 2000 and 2001. Mr. Ghosh has received several awards for his meritorious service. Welcome, Mr. Ghosh. He is joining us and he will be addressing for a few minutes. And next, I would like to introduce another guest of honor, Dr. Amlan Chakrabati. He is a professor in the A.K. Chowdhury School of Information Technology at University of Calcutta. He was a postdoctoral fellow at the School of Engineering, Princeton University during 2011 and 12. He has 2 decades of experience in engineering education and research. His areas of research and machine learning, computer vision, reconfigurable computing, VLSI, CAD, and quantum computing. Dr. Amlan has several awards to his credit, and some of them include DST Boycott Award in Engineering Science, Indian National Science Academy, that is INSA, Visiting Faculty Fellowship in 2014, JSPS Invitation Research Award in 2016, Eramus Mundus Leader Award in 2017. Almost every year he seems to be having an award. Hamid Visiting Professorship from University of Cambridge in 2018, Shiksha Ratna Award by Department of Higher Education in 2018. Dr. Amlan has served in various capacities in higher education organizations, both at national and international level. Further, he has published around 150 research papers in referred journals and conferences. Dr. Amlan is an associate editor of the Elsevier Journal of Computers and Electrical Engineering, guest editor of the Springer Journal of Applied Sciences, and series editor of Springer Transactions in Computers and Networking. Some of the credentials of Dr. Amlan include senior member of IEEE and ACM, IEEE Computer Society Distinguished Visitor, Distinguished Speaker of ACM, Vice Chairman of IEEE SIDA Indian Chapter, Member of International Water Association, Vice President of Data Science Society, and Life Member of CSI. Welcome, Dr. Amlan. You are kind enough to accept to talk about the trends in machine learning and also formally launch the book written by Dr. Vinod and Dr. Anand, and also offer some facilitations. Next, we have 2 distinguished speakers who happen to be the authors of the book, The Machine Learning, a Modern Approach, which has been brought out by Practitioner India. As you are aware, the machine learning has become one of the most wanted subjects of today. And while there are number of books are available in this particular field, the book written by both Dr. Anand and Dr. Vinod is different in many ways. The contents of the book are so placed that it bridges the gap in knowledge in the areas of machine learning and nature-inspired computing. In fact, machine learning draws a lot of insights from nature-inspired computing. So this book is a sort of amalgamation of both machine learning and nature-inspired computing. Each topic in this book are substantiated by well-explained algorithms and pseudocodes that helps the students to build self-sustained applications. Real-life examples and tutorial representations are used in a way to make deeper understanding of the subject that helps the readers to generate self-driven codes and applications. Further, the research-oriented approach of this book helps the researchers to build problem statements out of the case studies and examples presented. Basically, this book intended for the undergraduate, postgraduate, research scholars, computer science engineering, as well as the working professionals who want to gain some knowledge in the area of machine learning and its applications. So I have a pleasure in introducing both the speakers. I'll first start with Dr. Vinod Chandra. He is currently the professor and director of the Computer Center at University of Kerala. He has received his PhD from University of Kerala and MTech from QSAT Kerala, the Cochin University of Science and Technology. Dr. Vinod has discovered 4 microRNAs in human cell. He has 5 IPRs, that is, patents in the machine learning field. Further, he has authored 7 books and a modest number of research publications. Dr. Vinod is a reviewer of many international journals and conferences. His research areas include machine learning, algorithms, and nature-inspired computing. Dr. Vinod is heading the Machine Intelligence Research Group, a pinpoint research group in machine intelligence and nature-inspired techniques. Dr. Vinod is a leading many e-governance projects associated with universities and government. Further, he is involved in several consultancy activities for the government organizations. So he is going to be one of the speakers in today's talk, apart from being the author of the book. The second author, Mr. Dr. Anand Hareendran, is currently working as Associate Professor at Muthoot Institute of Technology and Science, Kochi, in the Department of Computer Science and Engineering. Dr. Anand has received his PhD in Computer Science from University of Kerala and MTech from Anna University, Chennai. Dr. Anand's current research areas include machine learning algorithms, association rule mining, and bio-inspired methodologies. Dr. Anand has authored 4 books, a reasonable number of research journal publications, and 3 IPRs in machine learning algorithms. Dr. Anand has further designed and implemented various rule mining algorithms which find applications in the field of medical, route mapping, and frequent item search. Dr. Anand is a reviewer in various international conferences and journals, an active member of Machine Intelligence Research Group. So having said that, so today's presentation will broadly cover how machine learning is being used in multiple fields and industries. Major application areas are medical diagnosis, image processing, prediction classification, learning association, regression, etc. And intelligent systems, how are being built using machine learning algorithms, which will have the capacity and capability to learn from past experience and historical data. And this presentation will also cover various applications like speech recognition, medical diagnosis, extraction, association, and financial services. Further, the authors who are the speakers will discuss how to build a model and how data is used for training. They will also discuss various types of learning, namely supervised, unsupervised, reinforced, and association, along with providing an introduction to deep learning and explainable artificial intelligence, a new field or in the area of artificial intelligence, which will be a stepping stone for the next generation of innovators. So with this brief introduction and welcome note, I also extend our heartfelt welcome to the PHI group, Ms. Shivani, the senior editor, and team members for making this presentation and this event possible. Now I would like to request Mr. Ghosh, the CMD of PHI, to address the gathering. Mr. Ghosh, please.
Yes, good evening everybody. Dr. Amlan Chakrabati, Dr. S.S. Vinod Chandra, Dr. S. Anand Hareendran, Mr. H.R. Mohan, Dr. P. Sakthivel, Mr. P.V. Subramanian, and distinguished participants. It is a privilege and great honor to address you on the occasion of the launch of the book, Machine Learning, a Practitioner's Approach, written by Dr. S.S. Vinod Chandra and Dr. S. Anand Hareendran, and published by us, PHI Learning. PHI Learning, as Mr. Mohan said, formerly known as Prentice Hall of India, actually PHI stands for Prentice Hall of India, was established in the year 1963. We are now in the 58th year in publishing. We publish high-quality, affordable text and reference books for students and professionals across the globe. Our imprint in Eastern Economy Edition, Mr. Mohan was saying earlier it was known, it is still known. Eastern Economy Edition is our imprint. On all the books, including the book which we are releasing, it will be having Eastern Economy Edition on one side of the book. And our motto is helping teachers to teach and students to learn. That is our motto. In 58 years of publishing, we have published more than 5,000 titles written by 2,000 authors, and most of them are Indian authors of Indian origin. And we have published in various disciplines covering all subjects. I simply say from agriculture to zoology. That means covers all the subjects you can think of. We are marketing our books globally so that the students from all across the planet, everybody can read our books if we can reach them. We have publishing partnerships with many renowned publishers and all university presses. Just to give example of two, MIT Press among the university presses and Microsoft Press among the professional publishers. Our books are followed by students and teachers all over the world, including the premier institutions in India, IITs, NITs, IIITs, IIMs, colleges, universities, technical universities. Our publications are included in the model course curricula of AICTE and UGC. All our books are published in print as well as e-format, e-books, digital format. Besides, we have got Kindle editions, Google Play, and Nook. Our books are available with all leading booksellers in India and abroad, and also on platforms like Amazon, Flipkart, Snapdeal. If you want to learn more about us, I encourage you to browse our website, phindia.com. Being a pioneer in publishing computer science, engineering, and technology books, we published the first pioneering work of Dr. Rajaraman, as Mr. Mohan was saying, Principles of Computer Programming. It was published in 1969. It was also the first computer book published in India, and it was published by us. We always encourage and motivate Indian authors to write textbooks on new and emerging technologies that prepare students of this digital age to excel in their career. Our book on machine learning that is being released today also falls in the same category. My deepest sense of appreciation and hearty thanks to Dr. S.S. Vinod Chandra, Professor, Department of Computer Science, University of Kerala, and Dr. S. Anand, Hareendran, Associate Professor, Department of Computer Science and Engineering, MITS Kochi, for choosing us as their publisher. I am grateful to all the participants for joining this event. On behalf of PHI Learning, I express my heartfelt thanks to you all for being with us and making this book launch a success. It has been a great pleasure. Thank you. Thank you very much.
Thank you, Mr. Ghosh. Before I hand over the floor to Dr. Amlan, I would like to thank PHI Learning for the generous offer in sharing the first chapter of the book to all the participants. And thanks to Ms. Shivani for organizing this content sharing arrangement. Thank you, Ms. Shivani. Now I'd like
Thank
to
you,
request.
Mr. Mohan.
Okay. Now I'd like to request Dr. Amlan to talk about the trends in machine learning and also formally launch the book. Dr. Amlan, please.
Okay. Very good evening to all of you. And thanks to PHI, thanks to IEEE and CSI Chennai for making this program. Great occasion. And it's indeed a great occasion because I see that two of my peers, two of my colleagues, Dr. Vinod Chandra and Dr. Anand Hareendran, okay, has come up with a very wonderful book. Okay, and it's a topic which is now a buzzword, which is now protruding to the various aspects, be in academia, be it industry, be it business and commerce. Okay, and obviously thanks goes to PHI under the leadership of Mr. Asoke Ghosh and the PHI team that they have helped the authors to come up with such a beautiful book. Okay, which will be very helpful. And now coming up to machine learning, as we know that so machine learning is a subject which is now being taught, now being cultured, now being worked upon, okay, in the various ways, in various aspects, right? And so to tell that what exactly we should fit into machine learning, where exactly machine learning will apply, right? This is becoming a difficult task. Maybe 8 years ago, we could have only tell that, hey, pattern recognition is machine learning. Okay, next we could have tell that, hey, robotics is machine learning. Right? Next we come up with machine vision is machine learning, right? Now, if you look into the aspects, right, forecasting, predictions, traditional pattern recognition, right, cyber security, right? Cyber security is having a great influence, and we have recently had got a great grant from Defense DRDO, where we will be looking into some of the areas, right, where AI and cybersecurity can merge, right? And if we look into the societal aspects of machine learning, that's really enormous, right? And that's why we see that it's not only now comes under the purview of computer science or information technology or electrical engineering. We see that the people from social science background, people from various other basic science background, right? Like the most influenced by the world of biology. I find that Professor Anand has already contributed to that particular domain of finding patterns and finding RNAs from the genetic data. So those are the areas where actually the people or the experts, the domains, the multiple domains, like be it medicine, be it drug discovery, be it agriculture, be it finance, be it psychology, be it human perception. Okay, this is the particular subject, right, where we have seen that we can do a lot of contributions. So to the especially for the students and young researchers, right? This domain and to get a knowledge in this particular domain is very important. Now, when we tell that what is actually machine learning, it is also a lot of things are there in the particular subject of machine learning. We can speak about the mathematical tools or recipes which are used in machine learning. Okay, we can discuss it, or we can write a great book on that only, that aspect of machine learning only. Right? If you get into the machine learning models, the statistical approaches of the machine learning model, and the way the data science and machine learning got merged, right? How machine learning uses data, how the models are built with the data, right? And what are the ways they are validated or their performance are measured in terms of statistical metrics. That is also a very elaborative task to do, or elaborative knowledge to have. Then it comes that how we implement this, right? How we implement the machine learning in terms of implementing into a specific system or specific platform, be the platform is a web, be the platform is a robotic engine, be a platform is an autonomous system. But that comes, that is again a bit exploratory, which is very domain dependent. Okay, so we need to have the domain knowledge where you will be applying these models, and we will actually make the models to act in the domain, right? And last but not the least, which is coming in a great way, which is ethics, right? Which is, that means how we tell that the outcome, what the model is generating, or the way we try to find that we can depend on the model, right? So there are a lot of things are coming up in that domain, that whatever model is doing, whether so when I go to the doctor with my computer-aided diagnostics tool, the tool tells that this is a cancerous tumor, or this is a not cancerous tumor. Now the next level is that the doctor is not satisfied with that particular answer, a black box answer. The doctor will be interested to know that, hey, why your tool has predicted that this is a cancerous, and why your tool hasn't predicted that this is not a cancerous. Okay, so that is called the explainable AI. Okay, part of this machine learning strategy, which makes AI or machine learning more dependable, right? So you see that this is really a great journey you have to do when you want to work in, or when you want to get involved in machine learning. But I thank the authors, that is Professor Vinod and Professor Anand. I have gone through the book, right, and I really thank them that they have tried to explain all the aspects, okay, of machine learning, right, from the mathematical recipes to they have also, I like that they have made a great emphasis of machine learning, which incorporates statistical techniques. Okay, many of the machine learning books, okay, just goes on to the implementation models. The problem what the practitioners faces only by trying to knowing the model is that they can't understand that how the model was built. Whatever the way they can, so a practitioner can think of building a new model, to build a new strategy, because then the mathematical understanding, the statistical understanding, and the understanding of the domain data is very important. And I find that this book gives a very good explanation, okay, on the mathematical aspects of the model. Further, this book gives a very good visualization, right? The authors have really worked hard to explain the models, not only in terms of language, in terms of some logic or reasoning, but they have also explained the models in terms of graphs, of visualization, right? Of how the model churns out the data, right? Where you miss and where you win. So those type of visualization is there, which is very important for the students to understand, okay, these models. Then they have also covered a vast part which is normally untouched in many of the machine learning books, okay, like fuzzy computing, okay, like the domain of fuzzy evolutionary algorithms, okay, they have covered the most recent evolutionary algorithm also, right, in this particular book, right, and that actually what it does, this book gives you a complete bouquet, right, a complete plate, right, where you can actually get every concepts of machine learning which is now prevailing at the present world, right? And now you can just learn the techniques from the book, try to understand the basic mathematical concepts so that you can, because it is most important to, because the models what the authors have specified, okay, those models are okay, that means are what you need to know. But when you work in the real domain, there are scenarios where you need to make the hybrid models, where you need to twist the models, right? For that, you need to know the model in great depth, right? And that understanding is there in this book, so that you know the models in great depth. So you know that, okay, as per your requirement, where you can tweak the model, right? And you can come up with the model which best suits your requirement, right? And that's where, okay, and that's where I thank the authors to they have taken it, okay. It seems that they have taken up a great journey, right, to plan the book, right, and to plan the content, to give demonstrating the examples, and last but not the least, this can work as a very good textbook, because a lot of questions are there, a lot of things the students can test themselves. The faculties can use the questions and the exercises which are given, very elaborate exercises they have given for each of the chapters, right? And so this book actually perfectly fits the requirement in terms of the knowledge development of the student or researcher or the professional. Secondly, it also helps them to build the knowledge in a very gradual fashion, right? The level 1, level 2, level 3, level 4, and the most latest domain knowledge and skills. So that's all from my end, and I feel that once the book comes into the market, right, I think this will be a very great demand, okay, to the students, not only in computer science or on electrical engineering, but students from the various domains. And most important, that means I have seen many people from industry, okay, they are now trying to okay, they were doing IT for a long time, but now they have found that they want to shift towards the domain of machine learning by learning the subject of machine learning, and they want to get into that data analytics, data science, machine learning domain. So this book is a right for those professionals also who wants to learn the subject and who wants to progress in the subject. Thank you all, and thank you once again. Okay.
Dr. Amlan, can you show the book and formally show the book and then release it?
So this is fine.
Yes. Yeah.
So this is
a virtual release.
Yeah. So this is for all, and I am really honored to release this book, right? And I hope that this will be a great success. Right? This book will be a great success. Okay, for the authors, for the PHI, and for the society at large. Thank you all. Thank you.
Thank you, Dr. Amlan, for your nice words about the book and also formally releasing it. So we are very grateful for your time, and I know that you have another program which is waiting for you. So thank you very much for joining us this evening. Thank you very much.
Thank you all. Thank you all. Thank you.
Now, may I request Dr. Vinod and Dr. Anand to take over the floor and then do the presentation.
Thank you.
Yes, we can pull out our banner.
Thank you, sir. First of all, I would like to express my sincere gratitude to the Prentice Soul of India for getting a chance to publish I think this is my fourth book with the Practitioner of India. Myself as well as Dr. Anand Hareendran did a wonderful journey between Practitioner of India, especially with Mrs. Shivani. I express my thanks to Madam Shivani and Mr. A.K. Ghosh, the senior most person in the Practitioner of India. And I saw even Dabla Mitra's mail also I'm seeing. She's also a contact person with me. So I'm very happy to see you once again. And also I am very sincere, express my gratitude to Dr. Mohan, who is arranging this meeting, the virtual meeting of releasing our book, Machine Learning and Practitioner's Approach, with the help of CSI, IEEE, SAM, as well as Practitioner India. I also express my gratitude to Dr. Amlan, who is the person, who is the correct person releasing the book to the academic community as well as industrial community. I also express my gratitude to all the members who are present over here for blessing us and the participation of this meeting. So now I just hand over to my point for contact to Anand for making the presentation.
Thank you, sir. I hope the screen is visible.
Yes.
So, first of all, I would like to thank the Professor Mohan, PHI, and all the participants for joining this particular session. So, I will just briefly run through the presentation. I would like to start from where Dr. Amlan left. So, he was telling about before, say, 10 or 15 years ago, machine learning was just telling about, say, prediction or things like that. So there will be a time, or the time is coming, where the machines will start talking to us as if he was a colleague of ours. So that's where actually machine learning is right now going through. So let me show you some of the basic applications where the machine learning can be used, and I will formally tell about the contents of the particular book. So coming to some of the applications, if you see the screen, you can see three words: network, vectors, and obnoxious. If someone asks you whether these three are words, we will be sometime confused with two words. About network, we are sure that there is a word like that. If it is a vectors, we are sure that the word doesn't exist. So if we say that the word exists or word doesn't exist, we have to tell about a probability. So we can say that the network is a word that will be existing and with a probability of 0.999. And cognifies is not a word, and with a probability we can say that only 0.001 chance is there for that particular word to be existing. So what about obnoxious? And what about the second script? Maybe a Chinese script. So we are not sure whether such a word exists or not. So when the way by which machine learning actually works is directly from the data that we are basically having. And the powerfulness of the machine learning actually comes when the data size is increased. So whenever we are telling about obnoxious or the scripting word, we are unaware about the probability by which the word can be existing or not. So let that be one particular example where machine learning can be used. We will come to all these questions later in the second half of the presentation. Now I'm showing a screen where there are numbers written from 0 to 9. And I need to tell which all numbers makes 2. So if I see that, we can see number of places where the number can be 2 or maybe not. There are different possibilities. Actually, for a human, if we ask, say, which are the two? So if I look carefully, I can understand that it's a number starting from 0 till 9. So after 2, the 3 has been started. So in between the 2 3s in the second line, I can see that that might be a 3. But will the machine actually tell you this? We can see that. Coming to another application where we need to do some forensics. Who wrote a particular letter? Okay, so by recognizing the handwriting, how can you tell who is the actual author of the particular text? Or you are giving me a text and I need to tell at what time period was this particular text was about, prehistoric or historic, or what time area. So finding the age of the text is another important area where this machine learning can be used. Same with the case of writings from Taliula, where we need to know which year or how we can decode the scripts on that. We also have various gaming platforms available. We have some checkers game available where so the checkers game, we are playing against the computer, where we are making some movement and the computer is playing against us. And after moving or after finding out some of the gaming capabilities, the computer actually starts competing against us. Identification of a particular person. It can be used in automated doors or automated gates. So identification of a face, that can be seen as another important application of machine learning. And if you are given a particular CCTV footage, or if you are given a particular image and you have to find out how many faces do you see, or you have to recognize a particular face from a CCTV footage. So how can you do that? So all these particular applications basically need a lot of computation. So how can we basically do that? That was one of the major issues when the machine learning started doing it. But there was an incident on May 12, 1997, where the chess champion Garry Kasparov lost a 6 games chess match to a computer named Deep Blue 2. It is where actually we came to know the powerfulness of computer. The computers were trained according to the movement that Garry Kasparov will be working with, and the computer was able to crack his movements, and computer was able to defeat him. And that's where actually AI and machine learning started to take a deep or steep curve in an exponential way. So actually, can the machines actually learn? That's the major question that everyone asks. So before asking or before telling, can the machine learn or not, let's see what is a learning. So learning is a process where the system improves its performance from experience. So consider two words, learning and natuto. If I ask someone whether learning is a word, everyone say yes, learning is an English word. What about natuto? We will be confused whether it's a word or not. But natuto is also a word in another language called Tagalog, which also means learning. So after this particular session, if someone asks you, say, do you know what a natuto is, whether there is a word called natuto, you can obviously say, yes, natuto is a word in another language called Tagalog. Here, what happened? You have improved your performance from an experience or the environment which we have now provided. So that is what exactly called as learning. So from learning, we can move to something called machine learning. So why machine learning and what actually helps to make machine learn? So machine learning is a process where we are developing systems which are too difficult or expensive to construct manually, just because we need to have more skills or knowledge to do a particular task. So this particular definition finds application in various fields. So starting from personalized news or mail filtering or personalized tutoring, from end to end, we can see that machines have a particular place where it is taking upon large amount of data and processing and finally giving you a result. We also have applications like market basket analysis, medical text mining, So coming to market basket analysis, whenever you go to a particular supermarket, you can see that products which are very closely related will be stocked very close by in the shelves. Why? Because people has a tendency to take items on together. So someone who is taking bread or jam, there is a concept like they will be also taking milk or egg along with them. So those will be stacked in a very close in the shelves. Or whenever you go to a library, a particular book written by a particular author will be kept together. Or textbooks which comes in a particular same domain will be kept together. All these are results of market basket analysis. So there are many effective and efficient algorithms available. But there is something that is more needed in order to employ machine learning. First thing is data. So right now we are on a digital era where the amount of data available is too good or in a very higher dimension. That's actually where machine learning finds this application. Only consider that I'm having only 10 or 20 or 100 data. I cannot do an accurate prediction or an accurate prediction about the next day or next future. Only if I'm having prehistoric data and only if the data are very freely available, machine learning can work. For example, stock market prediction. I'm very much interested in a particular company. I need to invest on that. How can I invest? I'll be taking all the prehistoric data or the analysis of the particular stock for the last 1 month or 2 months, and I will be finding, okay, this stock was increasing in an exponential way. So the chances that the stock market will be hitting high is very much on a higher level. So I will be taking that. So all those things comes in machine learning. So one of the major things that is lacking in machine learning is normally we extract data from someone called expert. Consider the case of a power plant. On a power plant, we will be having an expert who is basically taking care of the day-to-day power plant working. Consider I am a power plant expert. So at a particular time, there was an alarm going on. So being an expert on that area, I know why this particular alarm was now triggered. If I move that to a machine learning platform, machine might take 2 or 3 times in order to learn what exactly is the problem. So while building a machine with along with the historic and prehistoric data, knowledge from the experts is also needed. So then only we will be able to build a machine that is which is highly accurate. So we can see that we are in a machine learning can be seen as or any learning can be seen as either a black box learning or a white box learning. In a black box learning, we give the inputs and we get the particular output. But in a white box learning, we need to know how the process is being done. So what we, from a machine learning expert, what we need to look forward is we have to make the black box a glass box so that we will be able to understand what exactly happens. I will tell you a very good example for that. Consider that we have made a particular autonomous car, and I claim that this autonomous car will be working very well in, say, Indian traffic conditions. You can get into the car, start the car, and it can move. You can even sleep on the car. How many of you will take that particular trial or test run? Many might not, because we have a fear saying that, okay, in Indian conditions, will the automatic cars drive safely? But if the learning was a white box or if the learning was a glass box, you will be able to understand that, okay, my car has so and so sensors. If anything comes in front, the car automatically stops. So whenever the end user knows how the particular machine is actually learned, he will be more trusting about the particular application. So we have to make sure all the machine learning process are glass box or white box learning. So what all are the entities or who all are the stakeholders in a machine learning system? We need, as we told, that we need to have experts, we need to have prehistoric data, or we need to have resources which actually help us to build the knowledge base. We need to have a learning program, an engineer, who actually builds a knowledge base. From this knowledge base, we find the particular, or we actually build a particular model. In a real world situation, how this particular things are being graphically shown. We have an input data, we need to get the output. We are least bothered about things that happen in the particular in between. That is a very black box type learning. So what happens inside the black box is the algorithms and techniques. This is actually transforming the input data to the output data. So if someone asks what is the basic methods by which the process of transferring input to output happens, we can say that first process will be gathering data from various sources, including prehistoric data, data from the experts, etc. And we need to make sure that the data that we have is clean, it doesn't have any noise, and it is homogeneous in nature. Sometimes data will be coming in textual format, sometimes data will be coming in image format. I need to make sure that the data are homogeneous. Then I will be developing a model, finding the right algorithm for the right application. And from that, we will be testing the model and finally visualizing what is the particular output that we have obtained. So for any learning task, we can have three basic attributes. First one is a task, second one is a performance metrics, and third one is the experience. Here we have given 4 different examples. First one is on playing checkers game. Second one is on recognizing handwriting. Third one is on self-driving car. And fourth one on email filter. So what happens here is, whenever you need to run, or whenever you are working on a self-driven car, you need to make sure that all the sensors are in place and all the data that is being captured is actually processed in the right manner. Only after that we will be checking out for a performance metrics, where we will be actually judging for the errors and we will be re-repeating the process and make sure it is actually perfect. And then we will be doing some sort of trial and error method, and finally we will be fixing. So this is the learning task that is behind any machine learning process. So we can say that any machine learning will be having 2 different steps. First one is the training step, and then is the testing step. We also have something called validation step. So normally we use a 70-30 rule or a 60-20-10 rule for the training, testing, and the validation. So when we talk about machine learning, everyone talks about 3 basic scenarios: supervised learning, unsupervised, and reinforced. But we can see that nature-inspired learning is going to be the next boom of machine learning, because we know that the nature has provided man with lot of models which actually can be modeled, or which can be actually taken into for various optimization problems, starting from the basic ant colony, bee colony optimization, phototropic algorithm, to the latest killer shark algorithms, shuffled frog leaping algorithm. Lot of algorithms are there. So almost all the nature-inspired algorithms can be actually automated, and a new machine learning model for optimization can be built. So that also includes in the paradigms of machine learning. So coming to the learning part, we already told that there is supervised, unsupervised, and reinforced, along with the nature-inspired. So what is a supervised learning? Supervised learning, as the name suggests, we will be having a supervisor, and he will be actually telling us how the particular learning process happens. This can be actually illustrated with the help of a diagram. So this is the famous Jungle Book diagram. So here Mowgli is telling Bagheera that he is not able to understand the difference between dogs and cat. So here Bagheera acts as a supervisor who actually tells him, okay, these much are the dogs and these much are the cats. So he acts as a supervisor. So supervised algorithms are used in various applications like face detections, medical diagnosis, autonomous car, sound detection, or language identification. Similarly, we have another type of learning that is called unsupervised learning, where we will not be having a particular supervisor. We will be having unlabeled examples, and we have to make sure that the output produced is valid. If we consider the same case, same example, here even the supervisor is confused, or even they don't have a supervisor. So it is from the experience they are finding out the final output or classification between dogs and cats. So unsupervised learning is basically used in clustering, linear or dimensionality reduction, non-linear dimensionality reduction, and for finding learning rules. We also have another sort of learning called reinforced learning. which is also called as a reward or punishment mechanism. So here we will be having an agent to whom we will be providing some particular input, and according to the input, whether it was a reward or a punishment, the particular agent actually learns. Consider example of a dog. We are having a dog at our home. We are throwing a disc. The dog goes and takes the disc and comes back. If he takes the disc and comes back, we give him some biscuits. If he doesn't take the disc, we are not giving him biscuit. So this actually makes the dog learn, saying that there is a positive reinforcement whenever he takes or whenever he does an action. So he actually learns it using a reward punishment system. If I go and takes the disc back, I will be getting rewarded. If I'm not taking the disc, I will be getting punished. So for the biscuit, every time you throw the disc, the dog will be going and taking the disc and getting it back. So that is an example for reinforcement learning. The fourth most developing area on this machine learning is the nature-inspired learning method. It is basically used for optimization problem. So various models that have been inspired from the nature and various optimization models has been built. So starting from say genetic algorithm to ant colony, bee colony, cuckoo search, firefly algorithm, flower pollination algorithm, almost all the basic things from the nature has been taken or inspired, and learning models have been actually built. Actually, when we tell that machine learning is a very hot term or a very recently introduced term, let's see how the boom of machine learning actually implemented. Okay. We know that it all started with something called AI or artificial intelligence, and machine learning can be seen as a subpart of artificial intelligence because we are using some of the machine learning techniques, or some machine intelligence has been taken and some algorithms are being developed on that, and for that we will be basically using various neural networks. And we also have something called data science, which is basically used for the visualization of such results, and we have something called big data, which is also a subset of it. So this is actually how the basic terminology goes like. But our real question is AI, machine learning, neural network, data science, and big data new terms or new technologies? We need to be little bit doubtful on that, because all these things is a subset of what is called mathematics, probability, or statistics. Everything is built on mathematics. Like Dr. Amlan told, if you are going to write the mathematics of machine learning, that itself can be another 1 or 2 books. So whatever things that we say, it's an AI or machine learning, deep learning, a deep neural network, data science, big data, whatever be the bus term, the basic thing is the mathematics, probability, and the statistics. So whatever we have learned today or whatever we have discussed are actually learning that actually came from what is called as AI or artificial intelligence. So what is the future and what machine learning today is about? It's all about data. Machine learning or AI or deep learning is just possible because of the data, enormous amount of data that is around us. Let it be a handwriting recognition algorithm or let it be a voice recognition program. Whatever be it, if we are not having any data, it's impossible for a particular machine to predict accurately. So various applications, starting from we can have n number of applications. We can have an entire full day discussing on this application. I will just briefly tell 1 or 2 examples. Medical diagnosis is one of the major applications of machine learning. You can see if you are very much on this particular area, you can see that now the COVID-19 detection, various detection schemes are being implemented using machine learning algorithms. Credit card transactions, fraudulent transactions in any e-commerce platform can be found out using the machine learning algorithms. Spam filtering. As we are telling about spam filtering, there is a very interesting case. Consider that I am on the south part of India and I am checking on for an air conditioner. Next day, whenever you log into Facebook or Instagram, you can see a recommendation or you can see an advertisement of an air conditioner coming. That is not actually a spam, because there is a basic algorithm that is working behind it, an advertisement algorithm. But consider the situation, you are checking about an air condition sitting in, say, in the Kashmir. And next day you are getting a particular email on your computer saying that air conditions are available on 10% off. That is a spam mail, because spam filtering is basically linked with the region also. So Facebook or Instagram or whatever be the social, Amazon or any platform, they actually should work not only with a advertisement algorithm but also with a filtering algorithm, which actually classifies whether it's a spam or not. Similarly, the book recommendations or movie recommendation that you see in various applications or various apps in your mobile phones, say handwriting recognition, all these things can be seen as the applications of machine learning. I will tell you one more example where everyone is right now very much afraid about the data security or the data or the privacy. So one of the major examples, so these are the most commonly used application by everyone. So if we check the mobile phone, everyone will be having at least one of the particular application installed, whether it be Swiggy or Uber Eats or Amazon or Zomato. What actually, how the particular application delivers the foods incorrectly, not just because of the GPS. I had a very personal interaction with one of the company. I'm not naming the company. They actually is a company which provides application for the security people. So whenever a guest comes in a flat or villa, the security will take the photo of you and send to the particular resident of the particular flat or villa. And if he accepts it, the particular person will be allowed to get inside. So this is a very basic application that one of the startup started selling here. So their revenue model was very plain. They actually gives a yearly payment of 3,000 or something, and they don't have much. Customers. So I was very much skeptical about how do actually they run the business. After a lot of talk, in informal talks, they actually told like they are actually selling all the data. Let it be the person visiting us, let it be the people who are residing it. They are actually selling all the data to almost all the vendors who are shown in the figure. So what happens is whenever a package arrives, the Amazon or whatever be the customer, he actually knows where exactly the person is living or where exactly is the location. So a lot of data transfer is being happening. So machine learning is very much useful in cyber domain in order to prevent data leakage or data security. This is one of the hot topic nowadays, and for that, one of the major buzz terms called blockchain is also being implemented. Blockchain in a very layman definition, we can say that if I'm having 10 different nodes or 10 different places, I'm having a whiteboard. If someone writes on that whiteboard, on all the 10 whiteboards, the same thing will be coming over there. And once you have written, it's a permanent ink. You cannot change it. And whenever you write hi, on the whiteboard it is not shown as hi. It will be encrypted and shown. That's the only difference. It's a distributed type database. So blockchain is being used in order to implement like-minded machine learning algorithms. So similarly with the Facebook and Instagram, which I have already told about the recommendation system, friends suggestion, or the particular advertisements that you see. The Amazon is also using various advertisement algorithms, which actually shows what exactly the particular data that what according to the browsing history they are actually showing this. And this is the cyber security area where machine learning will be mostly used in order to find an unusual traffic or a new malware detection or false human interaction. Consider that I am a legal user of a particular network. I usually log in at 9 and log out at 5. But if from the home I wanted to check an email or I wanted to log into that system, I am logging in at a late night, say 12 o'clock. The system will not allow me because they are detecting an unusual login. Even though I am a legal user, they actually cuts my login. Why? Because that's how the machine learning algorithm was trained to know no user will be allowed to log in after a particular time. So these are the various examples where the machine learning can be used on various real-time applications where machine learning can be used. I will end with this particular slide. One of the hot topic that is going to be or is already there is the cyber physical system, where almost all IoT, blockchain, cybersecurity, almost all areas has been basically covered on cyber physical systems. Machine learning on each and every area that has been mentioned here is going to be the next boom of the technologies. So with that, I'm wrapping up the session. Almost all the data or almost all the things that has been taken is from these two books, from AI Principles and Machine Applications from PHA and Machine Learning Practitioners Approach, published by PHA. So the book that has been released today, almost all the data or almost all the applications along with the case studies has been worked out and the examples has been shown in the particular textbook. So anyway, thank you all for your patient listening. Hope I was able to convey some of the message through this particular session. Over to you. Thank you.
Sir?
Yes.
Good evening, sir.
Yeah, please go ahead.
Yes, sir. Yes, sir.
Dr. Anand Hareendran is... okay.
Yeah, sir.
So, both of the session is over, sir?
Yes. So, yes. Any questions? Maybe we would like to take all questions.
Yes, sir. So, thank you very much for giving a wonderful introduction about the machine learning and introduction to real-life problems. So, there are some problems which were asked to the participants. So, I will read out those problems and I request you to provide the answers, sir. How to diagnose cardiovascular diseases using machine learning?
Which disease, sir?
Cardiovascular diseases using machine learning. How to diagnose cardiovascular diseases using machine learning?
Yes, sir. Actually, we had a work related to the transplantation of organs that was published in some journals like IEEE Transaction on Man-Machine Cybernetics, Informatics Medicine Unlocked, and other some journals, Public Health, etc. What we do is we have some certain clinical data of from UNOS data set with 333 records, 333 features, parameters. And we came to understand that most of the parameters are not that much important, like in the case of name, etc., that are not important. After removing that, we have some 157 attributes after principal component analysis. That is one of the machine learning technique we are using. That is one of the unsupervised learning technique. It's a converging method. Using principal component analysis, we just formulated into 27 properties, 27 features. Then we should make a model. So that model we take ANN, that is a forecasting method. First we tried with RBF, MLP, and CART model. These models were be taken and we just analyzed. As a part of design, 27 input nodes, then 3-layer network which is hidden, and an output node. Output node contains 2 nodes. That is either it is leads to a organ that can be transplant or not, or something. The same method can be adopted for a disease also. The thing is nothing but the diseased data as well as non-diseased data is available. First of all, we make it the parameters in the sense clinical parameters and non-clinical parameters. I think that's the way.
Thank you, sir. We'll move to the next question. Please suggest some new areas of machine learning where it can be applied. Please suggest some new areas of machine learning where it can be applied.
This actually the new techniques of machine learning is nature-inspired computing techniques are very new. For example, Firefly algorithm. It's a very new algorithm. SD algorithm. It's one of the new algorithm. So that type of agent-based algorithms are very useful. That is, and otherwise, directly machine learning techniques like bag of visual weights, deep architectures, deep SVM. These methods are new architectures, new machine learning techniques that can be used. Nowadays, we are not bothered about mathematics first. First, we make the model, then make the mathematics, then formulate it. This is a technique. That is a way why we are using this deep architectures first. Otherwise, NIC, nature-inspired techniques first. Okay, sir.
Okay, sir. Another interesting question about your book. What is new in the book?
That's a good question. Anand will tell you.
What exactly new about our book? If you take any machine learning book, this will be actually covering the very topological areas. The nature-inspired algorithms area will not be there in any of the machine learning books. The nature-inspired algorithms, starting from the fuzzy area, those are not covered in machine learning, but these are the areas or upcoming areas on machine learning. This actually helped the students in order to get a very hands-on experience. We have included various case studies, and we are actually given various problem statements which can be extended to for a PG program or to a PhD problem statement that has been included in the book. So what exactly make our book different is the case studies, examples, the fuzzy logics, the nature-inspired algorithms that has been included in the book, the mathematical representations of all the algorithms, of all the traditional, starting from the traditional algorithms to the algorithms very recent has also been included in the book. That actually makes the difference.
In addition to, I would like to, one more thing, in addition to, we have included nearly more than 60 case studies in this book. That is research problems. These are the research problems related to these chapters. 19 chapters are there. And also, we just hand over certain supplementary materials to the Prentice Hall of India. It is available as a part of this book. 10 research problems. Recently comes research problems where we explored. We just mined that 10 research problems along with the either source code of R language or Python, and it comes Wake also. So these are the in addition additional material that comes around more than 300 pages. That additional pages that also available for along with this book. Thank you, sir.
Yes. What will be the machine learning effect on education? Hello?
So is the question like, what is the effect of...
What would be the machine learning effect on education?
Machine learning influence on education, right?
Machine learning effect on education.
Yeah, okay. So the various techniques, like say, what we have told about the security, cyber security area, the blockchain, all those are the latest or the latest things that can be implemented in a machine learning. So whenever we say about inference, we can say that it's a process of using, say, a trained deep neural network in order to make predictions against some previously unseen data. So that can be actually what the particular answer to that question.
Okay, sir. The next question: how machine learning used in predictions, and how machine learning be used for designing an algorithm for the same?
Sir, initially, I would like to answer that is machine learning is basically designed algorithms which have some sort of, for example, hidden Markov model. It's a statistical model originated in the previous century. After that, a couple of years later, that is after 70 years, Rabiner, where we designed some techniques like in speech processing. But today, the machine learning technology is growing very fast. First of all, making the application, then make the algorithm, make its mathematics. That's the way. So, for example, we are just making the algorithm of last time myself and Dr. Anand, along with make an algorithm in based on phototropism. We got a patent also, that is phototropism algorithm. We just identify the application area, then make it into this algorithm, algorithmic set and mathematics. So this is the way of making the algorithm.
Okay, sir. The next question, how can we use machine learning in teaching chemistry? How can we use machine learning in teaching chemistry?
Not only in chemistry, but also in all the application of science, it is applicable. For example, in the case of, say, molecular chemistry, we want to identify a particular DNA sequence or say, we can say gene finding. Yes, computational gene finding problem, definitely across machine learning applications like artificial neural network, hidden Markov models, or random forest. These techniques are highly useful for gene prediction. So in the case of molecular chemistry, it is highly useful.
Okay, sir. The next question, how to be well versed in writing codes of artificial intelligence? And how to be well versed in writing codings of AI?
Normally, AI or machine learning can be implemented in Python mostly, or we are also using R. There are also MATLAB toolkits available for the implementation of the same, but still we will be basically preferring Python for the basic implementations.
Okay, sir. Next question, what is the most important notes to get skilled in machine learning?
The first and important way is to practice. That's the only thing that we can say, because for each and every application, the codes differ, the algorithms differ. For example, take an algorithm. For example, I'm having a classification algorithm. Sometimes it will be a text classification. Sometimes it will be an image classification. According to the application, we have to select the algorithm. So only by practicing, we will be able to understand which algorithm to select on which particular application. So practicing is the only way by which a particular user will be able to understand which algorithm to use in which situation.
Okay, sir. One last question. What about the reliability of the machine learning model?
Definitely, that is one of the good question. In our book, it is clearly mentioned in the second chapter what is the method of analyzing a model and what is the predictivity of the model in the case of in terms of sensitivity, specificity, scoring materials, ROC, etc. That's a way why we are analyzing a model. That's and we just evaluating a model. Simply say evaluating a model. We have a separate chapter also for that.
Thank you very much, sir. These are some of the questions from participants. Now I invite Mr. P.V. Subramanian, Chairman, CSI Chennai Chapter, for formally proposing the vote of thanks.
Previous, before that, can I ask one question?
Yes, sir, please.
See this AI and machine learning, there are issues like bias. In fact, many forums, they talk about bias. How machine learning takes care of bias?
Yeah, that one of the wonderful question by our Mohan sir. Sir, actually, in the case of supervised learning, variance and bias is the two terms highly correlated. When our data is highly converged into particular thing, the design model becomes a failure. That is one of the challenging tasks when we are considering a design. So there should be there should be an analysis of each data set based on variance and as well as bias. This should be very clearly mentioned in our book in supervised learning techniques.
Okay. How does deep learning differ from machine learning?
Okay, sir. I will take the question. Actually, deep learning differs from machine learning. So, in deep learning network, the features are actually automatically selected. So that's the basic difference. And I also see I will also include one more question that was in the chat. Is reinforcement learning a special type of supervised? So we can also say that in a reinforcement learning, we are not having the final correct answer. Actually, this is the agent actually decide what to perform. But in the case of the supervised, we actually know what should be the right answer. So clubbing together for both question, I can say that when we say deep learning, the features are automatically selected, and for that the nature-inspired algorithms can be used in a very extreme manner. And for the between reinforcement and supervised, in the reinforcement, the agent actually decides what we have to be the final output. But in supervised, we actually have know what is the output.
Thank you. Thank you. PBS, you can take over.
Okay. Thank you. Good evening, participants. On behalf of Computer Society of India, Chennai chapter, ACM Chennai chapter, IEEE CS Madras chapter, I thank Dr. Amlan Chakrabati, Professor and Director, A.K. Chaudhary School of IIT, University of Calcutta, for consenting to release the book Machine Learning, a Practitioner's Approach, and also offer Felicitation. I thank the authors of the book, Dr. S. Vinod Chandra, Professor, Department of Computer Science, University of Kerala, Trivandrum, and Dr. S. Anand, Hareendran, Associate Professor, Department of Computer Science and Engineering, MITS, who had also given a beautiful presentation on machine learning and introduction to real-life applications. I thank Mr. Ashok Kumar Ghosh, CMD of PHI Learning Private Limited, Ms. Shivani, Senior Editor, and Mrs. Lalitha and other management members of PHI Learning Private Limited for their support in this event. I thank Mr. H.R. Mohan, Chair of ACM Chennai chapter, for arranging this memorable event to benefit the members of our society at large and also other IT professionals and students. I thank Dr. P. Sakthivel, Chair, IEEE, who helped us in supporting this event. I also thank Dr. Akila, who helped in making all arrangements for this event. On 6th March, that is this day, we celebrate CSI Foundation Day. CSI was formed in 1965, same day. I thank all the participants for participating in this event and made it a grand success. Thank you very much.
Okay.
Thank you, sir. Thank you. Thank you all. Thank you,
Thank you.
sir.
Thank you, Dr. Vinod and Anand. And before we finally wind up today's session, I want to make few announcements regarding our forthcoming programs. On 12th of this month, we have a chatbot development for enhancing customer experience. On 15th of March, we have one more book release, Making Excellence a Habit, a presentation followed by a presentation combating diabetes. It's going to be on 15th of March. On 20th of March, we have a session on how no code is changing the way we build software, no code application. On 24th, we have demystifying cryptography and encryption algorithm. The webinar is going to be presented by another PHI author. On 27th, we'll be ending the month of March with a program on ethical practices in research writing, the traits of a honest innovator. So these are our forthcoming program, and we have already communicated our announcement and registration link. We expect our members to register and join and attend the programs. So with these few words, I would like to once again thank both the authors, Dr. Vinod and Anand, and Mr. Ghosh, the CMD of PHI, Dr. Amlan, for their time. And of course, I will not be completing my thanking without thanking Ms. Shivani and her team for making all the arrangements in terms of creating the teacher content, the chapter 1 of the book. And also we would like to thank the authors for graciously accepting consenting to present the first chapter free of cost to all the participants. Thank you very much and good night to everyone.
Okay, sir. Good night. Good night. Thank you.
Bye.
Thank you. Thank you, Mr. Mohan. Good night, all of you.
So wonderful evening we had.
Yes.
And Dr. Anand, you are very precise. You know, I mean, the presentation was very crispy I can say that.